Hello, hello. Today I have the answer to the ultimate question. That's the name of the puzzle anyway, or alternatively titled, I think, The Second Best Kept Secret. This puzzle is by Viking Prime. It has a 100% rating with over 20 solves on Logic Masters Germany, so pretty excited to try it out. Let's get to it. It has 4 stars as its difficulty, which I'm a little worried about in a Viking Prime puzzle for me, but I left myself plenty of time. The one thing that might happen is if I have a package coming today that I need to sign for, and if hopefully that won't come in however long it takes to finish this video. But anyway, let's get to the rules. I've got normal Sudoku rules, so digits 1 to 9 in every row, every column, and every marked 3x3 box. We have a bunch of normal variant rules. So along arrows, so digits on this arrow must sum to the value. Well, this one's not going to work. Let's try this one. Digits on this arrow, on this circle rather, are the same as the digits on any individual arrow point attached to the circle. So for example, if this was a 7, then this might be, say, 4 and 3, and this might be, say, 2 and 5. And these sum to 7, and these sum to 7, and that's all fine. We have partial Kropki dots. So white Kropki dots separate digits that are consecutive. So say if this is a 4, this might be a 3, this might be a 5. That would be okay. For this black dot, if say this is a 4, then this might be an 8, and this might be, oh, I just realized that's fog. Look, okay, luckily those aren't correct. Sorry, I'll have to think about through, but anyway, let's ignore that. So that could be 4, that could be 8, that could be 2. These just have to be in a 2-to-1 ratio. And then we have Renban lines. So this line here, well, I can say the rule, which is it's a set of consecutive non-repeating digits, or values actually in order, which I'll explain why values matter, they're not digits in a moment. But that means these are going to be the values 1 to 9 because those are the only possible values here, and this is 9 digits long. So this Renban is going to be the digits 1 to 9, or the values 1 to 9 in some order. It could be a 1 here, a 2 here, or a 3, right? They could go anywhere. They don't have to go in any particular order as long as there's 1 each. So this is essentially an extra region in terms of values. Along a German whisper line, so say this one, values must differ by at least 5. So if this is a 4, this might be a 9, for example. No 2 lines will occupy the same cell. Oh, I guess I need to know that for this Renban line. This is not 2 distinct Renban lines. This is in fact 1 long Renban line. And same, I guess that doesn't matter for German whispers, but same will be true here. And I guess throughout this fog generally, like this in theory could have been a Renban here and another Renban here, and another Renban here, and another Renban here, but it's not. It's 1 long Renban. And then the modifier, killer cages. So within each 3x3 box has a killer cage around it. And the sum potentially could be given in the top left corner here. Now, normally you would think, well, listen, let me do the fog rule first. So there's digits covered in fog. So if I place a correct digit adjacent to the fog, that will reveal the value in the fog. So presumably the only missing information I have is what's in the sum of these killer cages. And you might normally think, well, isn't that just going to be 45 for all of them? Because I have the digits 1 to 9 once each in each of these boxes, and 1 to 9 sums to 45. And sure, that's true, except that the values in this cage are not necessarily 1 to 9 because of a modifier called copycat cells. This is a 𝐒𝐑 invention. And the idea of a copycat cell is like doublers or other modifier cells. I'm going to place 1 each. I'm going to probably use red. Maybe I'll use blue and yellow. I don't know. But so let's say I use red for now. There's going to be 1 in each row, each column, in each box. And those will also be the digits 1 to 9. So I can't have I have to have 9 copycat cells. I have 1 in each row. I have 1 in each column, and I have 1 in each box. And what the copycat cells will do, and presumably these are here to track those, what these copycat cells will do is they don't take their own value. They take the value of the cell 180 degrees away from it around the center. So what that means is, say this cell, if this were the copycat cell, this would go, this would take the value of this, whatever it is. this cell would take the value of this, whatever it is, because that's 180 degrees around here. This would take this. So one of the reasons I'm so bad at copycat cells, I'm pretty bad at doing the 180 degree rotation, but hopefully we can manage to do it. And I think I've covered all the rules. There's a lot of rules here, but I think I did it. So let's reset so I know how long I've been taking and get started. So this is immediately interesting to me. I mean, I kind of want to just put a 5 here, except I don't think, I don't know if that's right, because I could potentially have a copycat 5, but I have to think about how that would actually work. So what I can do, right, is I can, well, I definitely have 4 highs and 4 lows in values here. I'm trying to think what happens if I put a copycat cell in here. If I put a copycat cell in here, no, it doesn't even have to be the same. I was thinking maybe it has to be the same high or low as what it's replacing, but I don't think that's true. I don't think that's true because, well, hold on. Can I put 5 not in here? If I put 5 not in here, it's got to be a copycat cell, right? I can't put a 5 in here because copycatting, I'm only sending digits from 1 to 9 to other digits that are 1 to 9. And 5 cannot be 5 away from anything between 1 and 9. So if 5 is on the green line, it's a copycat cell. But could that work? I think it could, right? I could do 5 as, say, 9. These could all be low. These could be, hold on though. No, because I need to put, hold on. I need to put 4, 5, and 6 in this box. And so actually, if there were no copycat cells, I couldn't put 4, 5, or 6. Okay. Right, so what I'm going to have to do is one of them is going to go here. I don't know which it is. One of them will go, so the reason I couldn't put 4, 5, or 6 here, the copycat cells, 5 we've already explained. 4 can't go here because wherever I put the 4, it's adjacent to 2 other digits on the German whisper. And the only digit 4 can be next to in a German whisper is 9, and I can't have 2 9s. I can with copycats though, right? So I could put a 4 here, have a true 9 and a copycat 9. And that copycat 9 is if the 4 here were real, the copycat 9 would be either 5 or 6, whatever is being copycatted. So in fact, this is not a copycat cell. So I'm going to use yellow or blue. I'm going to use blue for cells that are not copycats. Somewhere in here, I've got a copycat. Oh no, it's got to be a copycat 5. Wait, is that right? I have to put a copycat 5 because if I, no. I could put a 5 here. So I have a copycat something. I've got another, either 4, 5, or 6. Another one is here. And then I've got a real 4 or 6 somewhere on here that's next to the extreme digit opposite it. So if it's a 4, it'd be next to, say, a 9, and then a copycat 5 or 6, something like that. But I think that's all I can do there. So let's look at this arrow. Well, I need a copycat cell on one of these. So and the reason is if I don't have a copycat cell, then the minimum on the arrow is 1, 2, 3, 4, which is 10. And I can't, even with copycat cells, I can't do 10 in the circle. So none of those are copycats. I've got a copycat cell in this arrow somewhere. I don't think that helps me yet. So let's look. I also need a copycat cell in these circles, which I noticed when I was filling in example values here. So I guess the way to do that is that these are not copycats. Right, so there's no copycat in those because if there were no copycats on this ring of white Kropki dots, so let's say this was 4 and this was 5, like pick any 2 digits you want, doesn't matter what. If this is 4 and this is 5, you've got to keep going up because I can't go back down to 4. So it's got to go 4, 5, 6. It's got to keep going up to 7, but then 7 and 4 will not be consecutive. So the way this is going to have to work is, like, let's say this was a real 4. These would be a real 3 and 5, and this would be copycat to a 4. And the same thing's going to be true over here. I was thinking that means whatever copycat cell here is going to be the same parity, but actually it's not true because the copycats don't go in the same orientation here. So that's not, anyway, but these cells now I have some, so now, yeah, I know a little bit. I know what this is because of my mistake earlier, but I'm going to try not to let that influence what I do. So, so this has to be 2 or 4 because there's no copycat here. I can't go say 3, 6, 3. The only way to get 3 in a chain of non-copycat digits is either 1, 2, 4 or 2, 4, 8. The middle is going to be 2 or 4 in this case. Oh, and actually 2. Wait, how's that going to work? Okay, I can have 2 copies of this. So 2 and 4 are in this somewhere. Same here. 2 and 4 are somewhere in this chain, which means 2 and 4 are not on this Renn band at all. Right? I can put 2 and 4 here, and here, and here, but I'm not going to mark it in those. Which means I need to have the values 2 and 4 in here somewhere. Which means in this column, I need a 2 or 4. And in this row, I need the other. So one of these is going to be a copycat and not. Oh, hold on. Wait. How's that going to. Oh, no, sorry. I was thinking this copycat to here, but it's not mirrored. It's rotation. So this would copycat to, say, here. And so these 4 digits copycat to these 4 positions. So there will be a 2 or a 4 in these, and there will be a 2 or a 4 in these. But anyway, one of these is a copycat. So this is not, this is not, this is not. I can't say anything about these. Like I could still put a copycat here and have one here and here. I think that's okay. Okay, this seems fine. That has nothing. I keep thinking I can do something like getting rid of 2 and 4 from here and have this be a 2-4 pair, but that's not true because I only have one of 2 or 4 here. Does this ring interact with it? No, because I got no, because this copycat could even be on the ring. Okay, not sure. So let's go back to this arrow. What's the smallest I can make this? Well, 3 of these are going to be not copycat. So I can do 1, 2, 3, and then a copycat to a 1 of a higher digit, which is, so it's at least 7. Except that, how would that work with this? So if I have 1, 2, 3 here somehow, how would that work? Hold on. Is there no way I can put 1, 2, 3 with a copycat to a 1? Well, yeah, so because these Kropki dots are also on values. So if these digits are all between 1 and 3, then this digit's also between 1 and 3, but 1, 2, and 3 are taken. So that it can't be the case that all of these digits are between 1 and 3. All these values, rather, are between 1 and 3. Because if all these values are between 1 and 3, what that means is I've got the real 1, 2, 3 and a copycat all accounted for here. But then what do I put here? It's got to be at least 4. Well, okay, so hold on. That's what I said isn't true. I could have I could have 3, 3, 4. This could be a real 4. These could be 3s. And this could be a 1, 2, but that gets me to 9 already. So I can't do 1, 1, 2, 3, because then for here I have at least 4, and I can't put 2, 3 there. So that gets rid of 7. Can I get rid of 8 for the same logic? how would I make 8 in 4 digits? It's either 1, 2, 4, 1 or 1, 2, 3, 2. Either way, this is a 4 and 2, 3. Yeah, it doesn't work. So this is a 9, which is a digit, not a color. And now this gives me 42, the answer to the ultimate question. Which means that the cell I'm copycatting is 3 higher. So this whole thing sums to 42. So if I take a 4 down to a 1, for example, that would reduce this total by 3 and make my total value 42. So if I do 4 to 1, I'd have 4, 1, and then I would need, 4, 2, 1. So then the others would have to come to 8. So 4 would go to 1. I would need another one. I couldn't repeat 4. So it'd be 4, 1, 2, 5 or something. Hold on, 4 goes to 1 and we have 2, 5. How does that work here? Because what I really would have are 1, 1, 2, 5 in some order. And how would that work in these dots? These have to be the same parity. I couldn't do 1 and 5 because that wouldn't work here. So these both have to be 1s because 2 is kind of the wrong parity. Everything else is odd. So these both be 1s. This would be 2, but 2 is on this. So that doesn't work. So 4 is not my copycat here. Could I do 5 copycat? I'm thinking it might end up being 6 to 3. So 1, 2, 3, 3, with these being 3s and this being a 4 would work. But can I do it with 5? 5 to 2. So then I really have, so that's 5 to 2 is 2 2s. That's 4. I need 5 more. And the 2 is taken, so it'd be 1, 4. So it'd be 1, 2, 2, 4 is what I have here. So these could be 2, 2, 3 or 2, 4, 3. Either way, that's a 3. So this is either 3 or 4. And this is 4 or 5. Oh, wait, hold on. But the cell copycats to itself in this box. Not to itself, to the digit in this box. So 6, 3 doesn't work because those have to be here. And this cell copycats here and this cell copycats here. So that doesn't work actually. Oh, so it is 2, 5. Hold on. So then this is a 3, I think. Hold on. So hold on. 6, 1, 2, 3, 3 doesn't work because the 3 would be copycatted from a 6 according to this. And then 6 and 3. I mean, whatever the copycat cells have to be across from each other, either like this or like this. And so these are not both the same copy. These are not both the same value. These are different values, which means this can't be 4, 3, 3. This has to be 3. A little not telling you anything emoji on this sum, which is funny. But hold on, I get a 5. My 5 is done. I'm going to block it out. Because whatever my 5 is here is copycat. So my possibilities here are the real 2 or the copycat. Wait, did I mess that up? No, the real 2, the 5 that copycats to a 2 or a 4. Right, because my digits here are 1, 2, 2, 4. That's what sums to 9. And the second 2 is from a copycat 5. So one of these is a 4 for sure. One of these is a 2 or 5 for sure. The other 2 or 5 goes here with the real 1. So I did all this work, and I feel like I'm no closer to figuring out what to do next. I mean, this is perfectly symmetric in a sense that there's nothing differentiating this from this by this dot. Because the way this arrow is drawn is essentially arbitrary. I could draw the arrow starting at any point and going around in either direction, and it's the same. It's just these 4 cells sum to this circle. which is totally symmetric even though it doesn't look it. I mean, there's a lot of symmetry going on in this puzzle. This looks like it breaks symmetry from the arrow, but it does. I mean, these break the symmetry from a rotational standpoint, but I still get this kind of reflective symmetry about the negative diagonal. So what are these digits? These are 6, 7, 8. Which doesn't tell me anything, unfortunately, about this, I don't think. Okay. So then what is next? I mean, this is no help at all. I didn't know anything before, so let's stay here for a second. Is there anything? Does this have to be 5 to make this work somehow? Oh, no. What I know is that this can't be a 5 anymore. Oh, wait, hold on, no. No, sorry, this has to be a 5. It's the other way. This has to be a 5 because the 5 copycat cell is taken. So this can't be a 5 copycat. So the copycat on here is either 4 or 6. So this is now actually a 5. And we get another 42, which means the copycat here is a 4 because we either get 4 copycatting to 1, so I can have a 6 with 2 1s next to it, or a 6 copycatting to 9. If 6 copycats to 9, this is going to go up by 3. I should have immediately, from the title of the puzzle, known that's what was going to happen. But anyway, this 5 gets rid of this 5 and this 5, which means this pair is in fact the 2-5 combo, where one of them is copycat, which means none of these are copycats. These are not copycats, and these are now a 1-4 pair, but the 1 goes here. No. The 4 goes here, and the 1 goes here. Because the 4 has to go next to 3. 1 can't go next to 3 if there's no copycats. So, and this is basically done. This is just going to be finished by some kind of Sudoku on the columns. There's a 4. So these are not copycat either, actually, because the 4... No, hold on. These are not copycats because the copycat in this box is a 4, and these can't be 4. So there's a copycat here, which means these aren't, which is a not 4 copycat. It's something else. So something in here is a 4, which will be flanked by... No, the 4 is copycatted to a 1. So the 4 will go next to 6. So if, let's say this is 4, this will be flanked by 6 and 9. And the 6 will get the 1 next to it. So does that mean this can't be 4? Because if this is 4, one of these will be the 6 posing as a 9, and then one of these will be the 1. Oh, wait, hold on. I'm sorry. I think I thought about it wrong. If this is a 4, meaning it's really a 1. Yeah, one of these will then be a 6, and the real 1 will be here, which it can't be. So this is also, so neither of these are actually the copycat 4. So one of these, and the one corner is going to be copycat 4. Whichever corner it is, let's say it's here, is going to have next to it. Oh, but that means I know that these are low. So these are all 1, 2, 3, 4. These are 6, 7, 8, 9. These aren't 3. If this is 6, we get 1, 4, 2, 3. The 2 can only go next to, no, the 2 can go next to anything that's not 6. It's the 3 I have to worry about. So the 3, well, it can go, it just can't go next to 7. So one of these is a 3. So this is not 7. And this can't be 6 either. Well, no, because the 6, hold on. The 6 is a real 6. So 6 is next one. So this is not 6 either. This is 8 or 9. So now that this works with a 3. 6 is one of these. If this is 6, these are 1, 4. If this is 6, these are 1, 4. If this is 6, these are 1, 4. Okay, yeah. That works. The 4 is copycat. So this, but the 7 can't go next to 1, 4 because the 6 goes next between 1 and 4. So it'll be something like, let's say this is the 6. It would be 6, 1, and 4. It would be totally irrelevant which one it is. 7, 2, 8, 9, totally irrelevant, 3. Wait, so can these not be 7? Hold on. If this is 7, yeah, we get 2, 3 over here. 1, 4, 6. Yeah, okay. That, oh, see, these aren't 9 because of Sudoku. So we had a 9 here in the row. Okay, don't know what else goes on. So now can we do more with this now that we have some of these taken away? Or I mean, what about this? What are my possible digits here? 2, 3, 6, 7, 8. And well, 2 definitely goes in here because 2 is here. So this can't be 2. 3 is any of these. And then whatever is missing from 6, 7, 8 also goes here. But these aren't 9. Can I put a 9 up here? Yeah, we could do 9 double copycat 8, 7. Yeah, I was thinking that might not work with this 8, but this could be the copycat 8 because this copycat's up here. Does that mean? Well, I can't put a 1 here because 1 would need the real 2. So 1's not here. So 1, I kind of X-wing of 1's here because this is not 1 by the Kropki dots. This can't have a 1 on it because it would need the real 2, but the real 2 is in here. So I do get the real 1 is in here somewhere. The real 2 can't be here. So this can't be, so, and it's the middle digit. So the middle digit here is what's copycat. So I can't have 1, 2, 3 because I would need 2 2s. I can't have 2, 3, 4 because it's only the middle digit that's copycat, which means the real 2 and the real 4. Oh, wait, that's a lot of these actually. Because I can't have 3, 4, 5 because I would need the real 4. I can't have 4, 5, 6. I would also need the real 4, which is here. So this is, the 7 is in here for sure. The real 7. If this is 5, 6, 7, it's 6 and something copycatting to a 6. And all of this is going to apply over here as well. So it's either 5, 6, 7, 6, 7, 8, or 7, 8, 9. Either way, and all those digits are real, plus 1 digit copycatting to the middle of that 3-digit string. So which means if this is 2, 4, 8, we're immediately at 5, 6, 7. Oh, but the one of these is 2, 4, 8. One of these is 2, 4, 8. because if these are both 1, 2, 4, then 1 is also missing from here. I need to copycat to a 1, but I can only possibly have 2 copycats on this run band. So one of these is 1, 2, 4, and one of these is 2, 4, 8. And the one with 2, 4, 8 becomes very restricted. It has to be 5, 6, 7 with something copycatting to a 6. So either way, there's a 6 in here because it's either, so let's say this is the 2, 4, 8. If this is the 2, 4, 8, then this is a 5, 6, 7, which has both the real 6 here and something copycatting to a 6, but these 4 cells copycat to these 4 cells and vice versa. So the cell I'm grabbing also has to be over here. But that does not mean that this 6 could be the copycat. Like this could still be 7, 8, 9 with the 6 copycatting to 8. If this is 6, 7, hold on. Wait, how's that going to work? If this is 2, 4, 8, this is 5, 6, 7 with some other digit. It could be anything. It could be 1, 3, 5, or 9. Well, it can't be 5 because 5's done. It could be 1, 3, or 9 copycatting to 6. So the digits I can, and so if this is 1, 2, 4, the digits I can copycat would be only 5, 6, or 7. So it has to be 6 or 7. So I think that means I can't put a 9 here. Is that right? If I try to put a 9 here, no, I have a 6. Oh, a 6 can copycat to 8. Hold on. If this is a 7, 8, 9, then I have 9 double 8, say 7. And let's say that 6 is copycatting to 8. That would mean I need an 8 here, but I can't because 8's in here in the world where this is 1, 2, 4. Or I can only do 9, 8, 7 in the box where this is 1, 2, 4. But if this is 9, 8, 7, the 6 has to copycat to 8, which it can't because if this doesn't have an 8, then this does, which means it can't copycat to an 8. So there is no 9 here. There's a 9 here, which means there's a 9 here. And all that logic applies this way as well. This digit, I'll come back to this in a second, but I just had a thought. This digit's either 1 or 3. The low digit on this line, because there's no copycats involved, is 1 or 3, because it can't be 2, and it can't be 4, because that would need a 9. If it's 3, it would go with 8. So this is either a 3-8 pair or 1 with 6, 7, 8, which is not that exciting. Okay, so let's go back to this. Does this have to be both 5, 6, 7? No, this can be 6, 7, 8 and copycat this 7. That's okay. Yeah, that's okay. So these digits are 5, 6, 7 or 6, 7, 8. Yeah, 6, 7, 8 can copycat the 7 from here. That's fine. Okay. So I don't know how it's going to work. Hold on. But is there something where... So this, let's just say we're in the world where this one is the 2, 4, 8, and this is now 5, 6, 7. And let's say this is the copycat cell. I know that's a lot of this is, but it's all kind of symmetric arguing. I'm just thinking through a concrete example to see what that looks like. If this is the copycat cell, that means this is the 6. And that 6 will have to be real. Which means the parity alignment of these are the same. But yeah, that doesn't get me what I was hoping that would tell me something more about how these work, but I don't think they do, because all that's telling me is, like, let's say, again, this is the world with the 2, 4, 8. So this is 5, 6, 7. Let's say this is the copycat 6. This is the real 6. That means these are even as well, because this is copycatting to the real 6, which would be one of these. This could still be 6, 7's 8, and this copycat into the real 7. That works fine. And this could also be 6 being copycatted from this 6 and 5, 7 here. That works as well. I wonder if this 5 is how we're going to figure out which is which, because, I mean, to figure these out, I have to figure out that I have to put 5. Well, no, because these could both be 5, 6, 7. So I've got to somehow get an 8. And I don't know. I don't see how yet. Okay. So 2, 4, 6, 7, 9. I have 4 digits that are not definitely somewhere, which are 1, 8, 3, and 5. So between 1, 3, and 8, 2 of them are being used as copycats in these cells. Hold on. No, it's okay. Yeah. I thought I messed up earlier, which I may have, but I don't see it. Because my logic relied on 8 having to be in one of these. So it can't be. You can't have 9, 8, 8. Because that would imply that 8 is both real in the one with the real 9 and able to be copied, which it can't be because I need 8 in one of these. So that, I think, is at least good. 4. Where is 4? No. Okay. Can I do something with this now? It just feels so ludicrous that I'd be able to do something with this because, I mean, even if I suppose there are no copycat cells here, which is a wild assumption, there almost certainly could be. There are still so many choices for this cell. This could be 5, 6, 7, or 8. Yeah, I just don't see how that's possible to do anything with yet. I was thinking, do I need one of 6 or 7 here? But I don't. This could be the 6, 7 pair. And then I would need 8 here with something copying a 7 because I couldn't have a 5. So if this is 5, 6, 7, we get a real 5 here, 1 of 6 or 7. But if it's not, if I put 5 down here, then it's, whatever. So okay, so my copycats are 4, 5, and 2 of 1, 3, and 8. 2, 6, 7, and 9 are left. And the other of 1, 3, 8. If I could prove that the copycat here is 3, that would make these 1 and 8. Which would be pretty interesting, actually, from a... Wait, hold on. Is it possible? Could I have 1 and 8 as copycats here? So this 1, if there were 1 here, that would apply. This is the 2, 4, 8. So this would be the 5, 6, 7. 1 would copycat to 6. And here, 8 could copycat to 6 or 7, I suppose. Depending on whether there's... Oh no, if 8's the copycat here, then this becomes 5, 6, 7. And the 1 copycats to 6. But that's fine. I don't see an issue. Okay, so these 4 cells, I've got the real one I need real everything that's not 2 and 4, which means I need the real 1 and 8, which if this has the real 8, then the real 8 on the red band is here. If this has the real, oh, so hold on, this is not 1, 2, 4, 8. Maybe that's important. So this is 3, 5, 6, 7, or 9. It's probably 6 or 7. Yeah, I don't think that's helpful. Okay. But the broader idea here, so one of these has a 1 and the other has an 8. One of them has something copycatting to 2 and one of them has something copycatting to 4. And then I've got 3, 5, 6, 7, 9 to split between, yeah, the rest. Okay, never mind. It doesn't seem so helpful. These copycat to here. So I need a 2 or a 4 here, not here. Oh, so this is not 2 or 4, so this is not the copycat. Which means one of these is a copycat, which means these aren't. Look at this, which means this is a copycat. Wow. My first actual spotted copycat, I don't know what it is. But I know it copycats to 2 or 4 and it copycats to a 2. I cannot believe that. That is a glorious set of deductions there. So this is my 2, my value 2 on this wild copycat journey. I don't know what it is, but it doesn't even really matter. So this is not a 2 anymore. Since this is not a 2, what does that mean? We could have 8, 4, 2, 4, 2, 1, or 1, 2, 4. So this can't be 8 anymore because we need 8, 4, 2. So this is not 8. This doesn't quite get us where I want it to get us. 2, 2. I need a 2 in here, but not here. So one of those is a 2. None of these are copycat. It really doesn't matter what the copycat is here. That's going to be determined by what copycat cells I'm using and or digits. So the 4 is coming from here, which means those aren't, this isn't, which means this is not a 1. One of these is now my copycat 4, which means this can't be 6 anymore. This 4 can't be a copycat 4 because the copycat 4 is being used in here. Oh, sorry, that means the 4 here is one of these, so that's not 4. So this is 4. A little kissy face here. This is now a 2-8 pair. So this is now my 5, 6, 7 plus something copycatting to a 6. Which one am I? 1 and 3. So this is between these 4 digits are 1. Sorry about that cut. A little personal interruption unrelated to the package. Anyway, I'm going to see if I can get back into this. These are highlighted, and I'm not sure why. Sorry, it's been like a half hour. Okay, let's just look at the board and see what I can do. These ones look here. No, ones could go either of those places. Oh, sorry. This is a 5, 6, 7 triple with 1 or 3. The other 1 or 3 goes here. It says a 1, 2, 3, 9 quad. So that's 8. That's 2. This 8 makes this 7, which means that's not 3. That's 3. This can't be 6 anymore, so that's 6. This is my 1, 4 pair. So now I need a 1 here. Oh, but I need a 4. Those are both copycats. Hold on. No, sorry, this is where I just came back to. Right, I got a 1, 2, 3, 9 quad. That's right. Forces the 7, forces the 3, forces the 6. Yeah, and then I get copycat 4 and copycat 1 here. Because 1, 2 pair force. This can't be 1. This can't be 1. Okay, so I have a mistake earlier than this, I think. I really thought I was in a groove before but clearly I've made an error somewhere. I'm just going to back up a bunch and try going forward. Probably not before this. Well, I hope it's not before this. Okay, so, right, that is, we got lows here because I needed a 4. Because that sum gives me 4 going to 1. So those are low. These are high. That can't be 3 because of that 3. One of these is a 3, so that can't be 7 or 6. Okay, or 6. Those can't be 9 by Sudoku. Don't need a 9 there. 2s, 3s, 1s. Why 1? Why is that a 1? That's probably the mistake. So I think I can put a 1 here. Yeah, that's got to be it. Did I use that? Hold on, I don't think I used it because I had, I mean, clearly those can't be 1s and these can, so if I don't use the 1 ever, I'm just going to go up to where I was and before I deleted those 1s and get rid of those and see if that fixes the problem. Yeah, because I definitely didn't get rid of 1 from any of these cells with that pencil mark. So let's, or do anything in box 9. So, okay, so what should I do here? Same thing, 1, 2, 3, 9 quad says that's 8, that's 2, that's 7, that's 3, that's 6, that's 8. This is now 2, 3, 6. This is not, this is a 1, 2 pair. None of these are. It says my 4 copycat cell is going to be here. 6 is definitely here with 5 and 7 because my copycat is in here. 1, 2 is here. So this is actually a 3, 9 pair. Yeah, so I do get a 1 here, in fact. Oh, not 5 because of that 5. So this is a 5, 6 pair. I need a 9 there. I definitely need a 4 here, but not here. What are these digits? 1 and 7. These aren't copycat by this. These digits are 4, 5, 6 only. Why can this? I have pencil mark 4 here. Why can't that be 4? It can't be 4 because this can't be a real 4. I don't know if I knew that beforehand, actually. I might have had a bad pencil mark there, but this can't be a 4 because I can't get a, if this were a real 4, I'd have a real 5 plus here, which doesn't work. And it can't be a copycat 4 because then this would be 5, 6 real, which is 11. So there is a 4 here, whether or not that pencil mark was earned. Can this be a 5? 5 would need 1, 4 here, and that breaks this. Because these are not copycat. So 5, this can't be 7. So 5, 1, 4. So this is, oh, but that could be a copycat 5. If it's a, right, same token, this is a copycat cell. Because if it's a 5 or 6, 5 needs 1, 4. 4 and 5 are done, that breaks this. 6 needs 1, 5. 5 and 6 are gone, that breaks this. So this is a copycat cell. So this has to sum to, these are both real. So I can't put a 6 in there because that'll break it. So this is a 4 or 5 pair. And this copycat's to 9. This therefore is 2 or 8. I don't know which one. I really thought I would know. I'm looking at the time and it's like an hour and a half, but I think that's just because I walked away and left the timer on. And I don't think this is going to be a 3-hour video. This is not copycat. I guess I should say this 6 is now accounted for, which means this is 2 or 3 now. Nope, I don't see any more Sudoku. This needs a 4, 2 or 5, and 6, 7. Oh, copycat. This is not a copycat anymore, which means that is the 2. The 5 is the copycat. For some reason I have what's new copycat in my head now. Sorry about that. Okay, 1s could go anywhere. 4s, no. Oh, these are not copycat, which means those 2 cells in box 1 go here. So these 4 cells are 2, 4, this cell, and this cell. Oh, and this is 1, 2, 4. And I get another not helpful emoji taunting me. I hope one of these, I don't know if I hope one of those is. I doubt they will be. Useful. There are going to be different ways of saying this. So Viking Prime is the cheekiest setter, I think, in existence. And this just proves it. 2 looks down here. I should do more Sudoku. So then I should know something. 1 goes in here. This is a 1, 4 pair. Oops. 1, 4 pair. This is 6, 7, or 8, but not 6. So there is a, that's not 6, because these are going to be the same. I need in here a 5 and a 9. 9's not here. And then the non-7 or 8 digit goes here. This could be 3, 8 still, I think. What can this be? Can't be 1, 2. It could be 3. Can't be 4, 5, or 6 because they're not copycatable. Can't be 8 or 9. So there's only 2 choices here. If this is, well, where's my copycat 2? Where's my copycat 2? It's in here because it's not here. It's not here. It's not here. It's not here. We're the same 2. So it's got to be here. So my copycat 2 is, the location roughly is known. This is my copycat 1. So between these 4, I have 3, 7, 8, and 9. now I have an awful feeling that this 9 pencil mark is wrong. Because I think I rolled 9 out of here. I think I rolled 9 out of here by saying it couldn't be a 987 quad, but that doesn't stop me from having a 9 copycat in here. I'm just going to delete this. I'm just going to delete it because I think it's wrong. And if I used it, I don't know what I would, because there's nothing down here. If I can re-earn it, I'll get it back. And I didn't use it for this. Okay, so I'm just going to move on from here. I was thinking that would give me a 9 down here, but if that's wrong, that fails. So then the copycat in here is 3, 7, or 8. Oh, hold on. This digit shows up here. Because where does this digit show up in box 1? These 4 digits are 2, 4, this digit, and this digit, which are both not this digit. So this digit can't go in here. Can't go in here by Sudoku. So it's got to go in one of these. So this digit is in one of these 2 spots. But that doesn't help me at all because it just tells me it's not 1, 2, 4, 8, or 9, which leaves actually 5, 6, or 7. That's not terrible. I'm trying to get this quintuple down to something reasonable, but it's 3, 5, 6, 7, 8. And I don't see how to get it more. Yeah, okay. I don't see it. I need... And there's no 1 in here because these aren't 1. So my 1 goes here. So that's my 1 on the Ren band fulfilled. So my 1's fulfilled. This is going to be my 2. This is going to be my 4. I still need a 3. Which could be literally anywhere. Well, can this be a 3? If this is a 3, I can't put another 3 on the Ren band. And I couldn't make this a 3 because then there... Oh, no, this could be a 3. Yeah. What am I thinking? In fact, this almost surely would be a 3. Not almost surely. I don't know. I have so many doubles, but I think the doubles are all... I think they're all good. Um, 3, 7, 3, 7, 8. I think this can't be a 7. I think this is 3, 8, or 9. And this is 7, 8, or 9. So this isn't 3. No. Okay. I mean, that's right, but I don't think it's helpful. Let's think about the whole Ren band, which I've been trying to do and failing. Maybe we need to think about it in the context of a specific digit. Well, let's see what this being 7, actually. Because if this is 7, that makes this 3. And then I have to put it... So, okay. Well, I guess one of these is an 8, but by Sudoku. Well, if this is 7, this is a 3. I need an 8 here. These become a... I would need a 3 here and a 9 here. but that's okay. I think. I'll be wrong with that. This is an 8. We get an 8 here, but that does like nothing. Wait, hold on. I need an 8 on the Renban. My 8 on the Renban has to be real. And the problem with this now being a 7 is if this is a 7, I now need, this has to be an 8 copycat. Because if this is a 7, this is a 7, this is a 3, I need an 8 copycat here, and then there's no 8 on the Renban. So this is an 8. This is my real 8. And it's not helpful. Well, I already knew what the copycat was in the cell. So I guess I could have known where it was if I knew this total, but that's okay. I got my 8 digit, which gives me another 8 here. So there's now an 8 in here. Three, 5, 6, or 7. Oh, that's too many choices. Oh, but now it's a 3, 7. Okay, now 3 and 7 are these two copycats in some order. I was thinking there might be some link here, but I think it can go. If this is a 3, I think it can go either way. If this is a 3, I think I can still put a 3 here. Like this could be a 3-7 pair, and this could still be a 6. I was thinking this had to be a 3, but I don't think that's right. And I don't quite see how those link yet. I feel like they're going to, but I can't show it. Two, 4, 8, 3 or 6. We need 5, 7, and 9. No, 5 and 7, and then the missing one. Okay, yeah, not helpful. Okay, was it only 3, 6, or 7? It's the only thing that can go here by Sudoku. 5, 6, or 7. This can't be 5, this can't be 3. Neither of them can be 1. That's almost helpful. My scanning is just absolutely failing me. I have no idea where to look next. I have hold on. If this is a 7, I still need a 7 on the Renban. The problem, if this is 3, I get it. I can get it here. But if this is 7, so maybe I can rule out 7 if this works. If this is a 7, I'll need a 7 here as well. And then look. These cannot be the same. These cannot be the same, and they can't both go in here. So I think actually what that means, this is going to have to be a 7. Wait. Yeah. Well, no, it doesn't have to be a 7, but it has to be 3 or 7. And it's going to go in here. But so let's start with this. I think this can't be 7. Right? But these can't be the same because they're both not copycat cells on a Renban. But these two cells, this cell goes in here because it's not on the Renban and a non-copycat cell, and it's not here by Sudoku. So it's got to go here. So this digit goes in here, which means these digits are 2, 4, 8, this digit. And this is not 2, it's not 4, it's not 8, and it's not this digit because they're both on the same Renban. So where does it go in box 1? It's not in here. It's not here. It has to go on here. But it can't be on a non-copycat cell. So this has to be a copycat cell in here. And these can't be the same. Oh, I'm so close. This has got to be it. This digit, yeah, will get copycatted up here. Will be the copycat cell up here. But that might be it. I thought I saw a problem with this being 7, but maybe not. If this is 7, this is 3. This is a 3-7 pair. If this is 3, this is 7. 7's copycat up here. But then it's fine. Yeah, I know, it works. I really felt like that was going to be it. I felt like I had it, but it did not. These are from 1, 5, and 6. And that didn't help me at all in the columns. Hold on. No, I don't see it. If this is a 3, we get a 7 up here. Wait. Both of these cells have this problem. This is gonna be a 3-7 pair as well, because this cell goes up here as the copycat. But where does this cell go in box 1? This cell goes in box 1. Not in. Oh, it could. No, these could both be 3. These could both be 3. But I think that means this is a 3. No, sorry. I think it means this is a 3, which will then make this a 3. Because if this cell is a 7, where does 7 go on the Renban? Not here, not here, not here. It'd have to go on here as a real 7. And then this would be 3, and we get a copy. So if this is a real 7, this is a 6. Sorry, if this is a 7, not a real 7. If this is a 7, the real 7 is going to go up here. This will be 3, this will be 6. If this is a 3, this will become a 7. My copycat 7 will be here. No, I think I'm wrong. I think that's fine. If this is a real 7, I don't know why my brain can't think this through. If this is a real 7, not a real 7, this is the copycat 7. This is a 3. We get the copycat. Hold on. If this is a 3, if this is a 7, we get that's a 6. If this is a 3, what happens? If this is a 3, I think I could still put a 3 here. Let's just with it. What happens if this is a 3? There's no 3 here, which means that's not 3. So we have 3, 7, 3. 3's in here. Yeah, that's okay. Three, 7, 3. I get a copycat 7 up here with 5 or 6, and that's 5 or 6. Yeah, hold on. Does this cell have to go in here as well? No, because this could be 6, 6, 6. It's very confusing to me. Yeah, I feel like there's just one too many levers you can pull there. Okay. Well, okay. No, 3, 7, 8, 9. So my copycat here is 8 or 9. My copycat here is 8 or 9. Does that help? If my copycat is 9, I get 9s going on. If my copycat is 8, I get nothing. So is there a problem with this being a 9? I get a 2-9 pair here. I don't see. Sorry, excuse me. I don't see the problem there. So, is it this? Can this now not be 3, 8 because of this? If this is 3, 8, we get 7, 3, 7. That's actually the less restricted option here. Because this 7 becomes copycat up here. We do get a 9 here, which puts an 8, a copycat 8 here, which means this is 5, 6, 7, 8. And this is 3, 9. Oh, sorry, this 2 looks here. Let's start with easy Sudoku. Which puts a 4 here. Okay. How long have you been yelling at me? 1, 2, 3, 5, 7, 9. There's definitely a 7 here. X-wing on 7s fixes this. But not in a way that helps me resolve anything. This is only 3 or 7. So I get a 3, 7 pair. There, so I do need a 1 in here. And I know where it goes, which is here. These 3 digits are 4, 6, 8. But this one's not 4 by the German whisper. So I definitely have a 4 here. Wait. Yeah, 3, okay. No, X-wing on 7s. Like, how did I get X-wing on 3s? No, I have an X-wing on 7s. I'm not going to go back because I don't want to if it's not wrong. I don't know if it's wrong. 3, what am I missing here? No, 2 looks down here. I wonder if that's been around forever as well. 3s. Oh, this isn't a 6 because of a 2, 3, 6 pair here. Triple, I mean. These are 5, 7, 9. Could this be 6, 7, 8 with 9 copycat to 8? So it's a 7, I mean? I think it could. If the 8's copycat here, I need 5, 6, 7, 8 copycat to 6. And those are in different spots. That doesn't help me. Well, one interesting thing is I can't have an 8 copycat here in either of those cells. Doesn't mean I can't have an 8 here, but I can't have a copycat 8 here. Because if I have a copycat 8 here, then, so 8 in this box goes in one of these 3 spots. And if I put an 8, a copycat 8 here, that tells me that this cell is both an 8 and copycat, which will double the copycat 8s. But I could still have a regular 8 here with a copycat 9 somewhere. Which means if this is a copycat 9, it goes here. I wonder if that's helpful. And then I would do a copycat 8 here. And the copycat 8 would go to a 6. So in fact, a copycat 8 could only go here to copycat that 6. And this would be copycat, this would be 4. I don't need to do that. I'm sure I don't need to do that. Yeah, I don't see a problem with these all being 3s. If this is a 3, I think this could be either. What do I do now? I will come back to this. I need a 5 on this Ren band somewhere, which will go in here. Well, could this be a 6? I think it could. Yeah, easily. It could easily be a 6. Well, it makes this a 6. No, don't know. If this is a 7, that's a 7, which will go up here as a copycat. That'll be my 5. This will be a 1-5 pair suddenly. That becomes 6. That becomes 6. So 7 forces this to be 6. I get a 1 here. I always have a 1 here. 7 forces this to be 6. I don't know how that helps me. I think because yeah, 7 forces a 1-5 pair here. Let's think about a copycat 8 here again, because I'm starting to think this is going to have to be a copycat 9, and then I can put an 8 in here, which would do something. So my copycat 8 could only go here. Could this really be a copycat 8? That would force an 8 here and make this, because my copycat 9 would go here. So the reason the copycat 8 can only go here, I can't put it here because that forces this to be both 8 and copycat. I can't put it here because then a copycat 8 would copy to here. But as a copycat 8, there can't be a real 8. So this is a 5, 6, 7 triple. So this has to be a 6, which it can't be. This could be a copycat 6. But if this is a copycat 8, that's not copycat. This is my copycat 9. My real 8 goes here. 6 goes here and here. And I get a 1-6 pair here. In fact, this would be a 6. This would be a 6. This would be a 6. Oh, hold on, that's going to break. I can't put a 6 here. I cannot put a 6 here. Yeah, I can't put a 6 here because then I'll get a 6 here, and that just doesn't work. So my 6 in this column has to go here, which puts it here. There we go. That is this. That is the way. This is now a 1-5 pair. I saw it because of blatant bifurcation, but the step itself is fairly straightforward, I think. This can't be a 5 anymore because this. Oh no! This cell is a 5 because it goes here. 7 now goes up here for sure. Well, let's just do 3, 6, 7. This cell goes in here somewhere. Now the 8s here matter, right? Because how do these copycats 8s and 8s and 9s resolve? This can't be a copycat 8 anymore because no matter which way I do it, wherever I put the copycat 8, it makes the copycat and the 8 go in the same place down here. So my copycat up here is 9. And my copycat down here is 8. And my true 9 therefore can't go down here. It has to go up here, which gives me a 1-9 pair down here. And I can't go down here for the same reason that I couldn't have 8s and 8s working, right? If my 9 was down here, then wherever my copycat 9 is up here, the other cell will be both 9 and copycat. So I can, well, I'll leave the 8 there to remind myself it's copycat, but this is a 5-8 pair. I should know this is a 9, right? Yeah, so that's more straightforward. This 6, this is now a 4-8 pair. This should be a 2-5 pair. This should be a 3-8 pair. Then what? My 9's a copycat. Oh, but I still don't know. Well, this is a 5 here. So this is 6, 7, 8, 9. With the 8 copycat, the 9 copycats to 7. So the 9 is actually up here, which means I get 7, 9. 9 copycats up here. I don't know where the 8 goes. Right? It could be any of these. 8, 9, 7, 8, 6, 7, 8, 6, 8, 9. This can't be, no, that could be neat. I still don't know what's going to be revealed here. This can't go to, so this can't be 42. So it's going to be an emoji. 3-8 here looks at this. Yeah. 3-8 here looks at this. Yeah. So my 3 goes up here for sure, which means that's a 6. This is a 3-7 pair. The 3 is my copycat. I don't get any sums anymore, except for ones I've already done. So that's not going to help me. Except I know the 3 goes with 4 here from the Ren band to work. 6 goes in here. Do I really not know? I have to know. I have to know how this resolves. Hold on. This can't be 8. Oh no, because 9 goes to 6. Hold on. How does this work? Eight, 7, 6, 9. But 9 goes to 7. If this is 9, it goes to 7. 7, 8, 7, 6. Hold on. There's only 2 ways this works, so there can't be 3 possibilities anymore. So if this is the 9, it's really a 7. And we get 9, 8, 7, 6. Right, that's one way it works. If it's really an 8, we get 8, 7, 6, and the 9 copies the 7. So those my center marks is one possible world. My corner marks are the other possible world. Also, the 7 was looking over here, which probably... And my 9. So yeah, Sudoku probably did the same thing. How am I not seeing this? Okay, this is a 2-3 pair. It all just feels like deadly patterns, but there must be a way to resolve it. So oh, it's probably Sudoku. Did I miss 1s, 2s, 6s? No. Really? Oh, 3. Yeah, there we go. 8. Yeah. Oh no. Hold on. I got another mistake. That's wrong. Hold on. I probably use that a bunch too. Shoot. Okay. To here is fine. That's not 3, 8. What is this? It's 3 or 4. 3 or 4. Okay, but I think it's all going to work the same. This has to be a 3. This has to be 6. This is a 3-7 pair. With the 3 as my... Okay, but 4. But this is going to resolve a bunch. I did something here, but let's... 5 fixes these. This is my copycat. This doesn't help this. These are not copycat, so they're not 9. 8 is over. So this is an 8-9 pair. This is a 6-7 pair because 8 has to go over here, and the copy. Sorry, this is copycat, not copycat. This is one of these is copycat, which is the 9. So the 8 and the 9 both have to go here. This is not 6. And now I had something with my 9 will copycat, because this is a 6, 7, 8 triple for real. 9's going to copycat to a 7. The 7's in here. So this is my 9, which is my copycat. My 2 is my copycat here. My 9 copycats to 7, which is here. That's going to resolve everything, I hope. 7 goes here. Whoops. My 3 is the copycat here. 1's the copycat here. Yes. Okay. Okay. I think I've finally done it. 3 looks here. 5 looks here. 1 looks here. 9 looks there. Where are 6s? 6 is down here. So this is 8. This is 2. This is a 4-6 pair now. 8 looks down to here. Looks to there. Looks to here. Looks to here. Gray out all those. This is a 7-9. Wow. I made so many mistakes. 6 by 9, 42. That's it. That's all there is. Always thought something was fundamentally wrong with the universe. It's a beautiful puzzle. There was something going on with like 2s and stuff on the run band that just blew me away. The whole thing was just on the edge the whole time. It was a wild puzzle to solve. I don't know. It's probably not the best puzzle to watch or to solve on camera, but it's a great puzzle. So thanks for setting it, and thanks for watching if you watched any of this. All right, I'll see you next week. Bye.